analysis of one bar element. For that purpose, we have to. Okay, so for the stiffness matrix, okay, calculation of global matrix and stiffness matrix is our target. Okay, in this problem, okay, structural analysis. Also, thermal analysis is also there. We will see later on. Now, suppose if you see here, okay, suppose if you see here, the one diagram is showing. Okay, spring is fixed with one wall. Okay, now spring is fixed at one end, and at one end we have added a force. Okay, force nothing but P. P is the force. Okay, now length is this is nothing but length distance of the length of that spring. Okay, now after that the displacement U is nothing but the displacement. Okay, U is nothing but the change in length is nothing but the displacement. Now for the calculation of 1D bar element, these are the very basic things. Okay, so don't panic about this. So we know that the stiffness formula for the spring. Okay, what is the spring is nothing but stiffness of spring is nothing but basic. You might be knowing spring is nothing but force upon displacement. So this is the basic formula. Now by moving, okay, force is equal to stiffness into displacement. U is nothing but displacement, and okay, force is equal to stiffness into displacement. This is a general basic equation. Okay, so to mark as equation 1. Now same logic we can apply to the find out stiffness of bar. Okay, this is the basic for the spring. Now for the bar calculation, bar displacement calculation, structural analysis of bar, same calculation or same method we can add here. Okay, suppose here instead of spring we have taken one bar. Okay, now one thing is remaining. Okay, in the spring, suppose we have taken two nodes here. Okay, where node is nothing but the where design consideration is there. Okay, where the analysis will be happening is nothing but the node. Now in this stiffness figure or in this spring we have taken two nodes. Okay, one as fixed end and second as forced load. Okay, is nothing but we have taken a forced load. For that purpose, for that entire geometry, two node we have taken. Okay, now same for the bar element. Okay, we have taken one bar element which is having one node at first end and one node at the fixed end. Okay, same thing is there. Length of bar is L, area is nothing but A, and displacement of bar after force. Okay, that will be U, displacement. Okay, now generally we know the stress is equal to stress is directly proportional to the strain. Okay, as we know that the so put the value of sigma is equal to E into epsilon. Sigma is equal to modulus of elasticity into stress. Okay, what is the stress? Sorry, strain. What is the strain? Displacement upon length. Okay, and what is the stress? Stress is nothing but the force upon area. These are the basic entities. So rearrange the equations. Okay, so rearrange the equation as compared to as in previous thing we have taken P as a P equal to spring. Now here we get an equation P is equal to AE upon L into U, where P is equal to force, A is nothing but the area of that certain bar, E is equal to Young's modulus upon L is equal to length of that bar and into displacement. Okay, two equations we have get here with the help of the previous basic knowledge. Okay, now this formula will be required for the. So by comparing equation 1 and 2, we will get K is equal to area by L. Okay, stiffness of spring is equal to area into Young's modulus upon the length. Now friends, here the very important thing. Here the 1, 2, 3. Okay, this is the one bar. Okay, we have taken one bar and we have taken three nodes here. Okay, where the first node is nothing but 1, second node 2, and third node 3. The distance between first node is L1 and distance between second and third node is L2. Okay, according to your requirement, you can add different elements and you can add different nodes. Okay, where three nodes are there, the two elements are there. Okay, because by adding two nodes, definitely we will get one element. Okay, this is a basic entity. Okay, so next we get equation K is equal to AE by L. Okay, this is a basic equation. So any doubt please ask me. आता मी पुढे जायचं पुन्हा मागे डाऊट राहतो तुमचा. आज कसं काय
तर ते नोटचं सांगा की रिपीट.
कोण कोण ओके 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 हा okay now node is nothing but the where the analysis will be happen. Okay, now suppose if you go to first slide. Okay, now this one element bar, okay, 1D element bar is there. Now different according to your requirement. Okay, we can consider the nodes. Suppose there one element is nothing but the something length is there. Okay, something L1 length is there. For that purpose the one element at the end of that element node will be definitely there. Okay, म्हणजे बघा मी काय म्हणतो इथं at the last. Okay, suppose see here at the bottom of this slide. Okay, U1 U2 U3. Okay, now this is a one line 1 2 3, this is a line and we have taken analysis for the purpose. Suppose if you see here now this is a 1D bar. Okay, we have to calculate different stress strain displacement of that bar. Okay, with the help of analysis, with the help of ANSYS software. Suppose this rod is fixed at first end and at the second end we have applied the force. Okay, now for that purpose if the dimension will be changed, okay, according to your requirement you can add the node. Okay, the maximum node contain the accuracy will be definitely maximum. For that purpose we have using the different nodes. Okay, so now your question is what is the node and what is the element. Okay, you are confusing in that. Now suppose here suppose see this is one fixed bar. Okay, L is length, P is equal to force, one bar is fixed at one end. Okay, now at the one end we have fixed at the end is second node. Okay, म्हणजे आपल्याला दोन ठिकाणी फक्त अनालिसिस करायचं. Okay, this is a not very confusing friends. Okay, now see here the line. Okay, 1 2 3, this is also one line but something length or something the dimension may change. Okay, according to your requirement you can add the node here. Okay, very simple. Okay, node is nothing but where the analysis will be carried. Where analysis will be carried is nothing but a node. Okay, and to hello, am I audible?
Yes sir.
Any doubt, Prajwal? Now, whenever we will solve the problem, okay, that all these things will be definitely clear. Okay, these are the only basic purpose. Okay, for the only formulas we are required. Okay, this is a theoretical part. So, by adding different nodes, okay, we can calculate the stress strain of that certain component. Okay, so now the stiffness matrix we can given stiffness into displacement is equal to force. Okay, in previous slide we have find out that equation. Okay, where here the first equation was force is equal to K into U. Okay, only by using rearranging we have kept here no sorry equation by equating equation 1 and 2, K is equal to area upon L. Okay, so if you move towards the second slide, okay, now stiffness matrix can be given as K into U into is equal to F. F is nothing but the force. Now what is the value of U? Okay, what is the value of K in previous equation? Value of K is equal to AE by L. Okay, this is a K into U is equal to F. This is a standard stiffness matrix equation. Okay, this is the standard equation. Now according to node, okay, this is a very simple. According to node, here we have taken two nodes here, okay, I and j, number of elements. Okay, now if the elements will be 2, then node will be definitely 3. Okay, one node will be fixed. Okay, now this is a for the two nodes. Now second stiffness matrix for element 1 is given multiplication is there. This is a standard formula, friends. Okay, U is equal to matrix we have added. Why? This is a standard matrix, 1 minus 1 minus 1 1. Okay, this calculation is very huge. Okay, very rigorous calculation there. Only due to that purpose we have taken only formula here. Okay, so don't be panic for that formula. Okay, so keep in mind, and while problem आणि ui and uj is the initial displacement at I and displacement at j. Okay, where we have taken the here. Okay, u1 to u3. Okay, I j two node we have taken here. Now the stiffness matrix for element 1 is given below. K1 only multiplication we have taken here. Okay, with the help of we have taken here K1 minus K1. So this is not important. Only final formula is important for us. Okay. So for the two node K1 minus K1 minus K1, K1, U1, U2, F1, F2. This is the first equation and this is the second equation. And global matrix is nothing but the addition of these two. Okay, equation 1 and 2. If the node will be 3. Okay. So moving towards directly problem. Okay. Problem is very simple. These are the formula very important for your calculation. Okay, first formula is K is equal to AE by L into our standard matrix of displacement. Okay, 1 minus 1 minus 1 1. Okay, only multiplication. This is the standard matrix. Now for this stiffness matrix we can give matrix can be given as K into U is equal to F. Okay, only we have added the value of K here. Okay, another is formula same. Okay, after that, what is here? This is very important for our calculation. This is our answer of problem. Okay, stress 1, stress at point 1, stress at point 2, and strain at point 1 and strain at point 2. Now, what is the strain? Okay, displacement upon length. Okay, that purpose U2 minus U1 and U3 minus U2. Okay, two strain we will get. So directly move to the problem. Okay. Calculate the displacement and stress in given below. Okay, one problem they have given, very simple problem. For the 4 marks, this problem will be asked. Okay, so here 1D bar element is there. Okay, calculate the displacement and stress is given. Okay, what we have to find out? First is displacement is nothing but the U, and second is stress. Okay, stress formula we know what is stress, force upon area. Okay, that formula we can add here. Now here, what is the given? Friends, in that problem given is one element is given. Okay, 20 mm area, 10 mm length of that bar. Okay, and 100 Newton force they have applied. Okay, so and Young's modulus they have given. Okay, our modulus of elasticity 200 into 10 raised to 3 Newton per mm square. This is a given formula. Now, what is the procedure for solving this problem? First of all, we have to find out the stiffness matrix. Okay, or what is the stiffness? K is equal to, we know formula AE by L upon into 1 minus 1 minus 1 1. Okay, if you require the that rigorous calculation, okay, we will take if possible we will take, okay, but this is not our syllabus. For our syllabus, so only we have taken only formula here. Okay, now put the value here. Okay, what is the area? A is nothing but area. Okay, area is given 20 mm square. E also given. Okay, Young's modulus is also given 200 into 10 raised to 10 upon length 10 mm. Okay, so friends, keep in mind all the units of given dimension. Okay, if a unit will change, definitely answer will be will get you answer will be definitely wrong. So try to keep in mind the first of all you have to equal all the units. Okay, but in this problem no need to all units are same. Okay, so k is equal to after calculation let it be 20 into 200 into 10 raised to minus a upon 10 1 minus 1 minus 1 1. Okay, k is equal to 4 into 10 raised to minus 5. Yeah, after calculation that matrix we have kept as it is. Okay, only 4 multiply by 4. 4 is inserted in matrix. Okay, what is the value of k? What is the value of k is equal to 10 raised to 1, 10 raised to 5 into 4 minus 5 4 minus 4 4. Okay. Now after again we have we know force is equal to stiffness into displacement. Okay, one formula we have studied. Okay, we got the formula k is equal to, so put the value k is equal 1 element is nothing but the 2 end. The end is then second end is at fourth point. Okay, where we have given load. For that purpose we have taken 2 nodes. 2 nodes is nothing but the 1 element. Okay, so for that purpose we have taken in matrix U1 and U2. Okay, node 1 and node 2 displacement at node 1 is nothing but U1 and displacement at node 2 is nothing but U2. Okay, now we have to calculate displacement at U2. Friends, we have to find out the displacement at U2. Why? Because this is given in problem. Okay, calculate the displacement stress in given below. Okay, suppose if you consider point 1, okay, point 1 is fixed. Due to that, the displacement of point 1 will not be there. Okay, only displacement of point B or point 2 is will be happen, and that displacement we have to calculate. Okay, so put the value U1, U2 is nothing but the displacement at point 1 or node 1, and U2 is nothing but at node 2 is equal to F1, F2. F1, F2 is nothing but the in standard formula. Okay, they have given. Now here also F1 and F2. Now friends, here very important thing, F1 is nothing but the reaction force. Okay, at the node number 1. Okay, definitely the reaction force will be there. Why? Because we have active load. Is it right? म्हणजे आपण 100 न्यूटन जर पुढे ओढत असेल तर whatever the reaction at point number 1 will be there. Okay, so for that purpose we have taken F1 point as R is nothing but the force at point node 1 is nothing but R, and F2 they have given, म्हणजे एका बाजूला 100 दिलं दुसऱ्या बाजूला काय, we have to find out. Okay, the reaction force we have to find out. Okay, only remaining calculation. Okay, after calculation we will get the value of U2 and R. Okay, now by solving the equations, okay, U2 is equal to 25 into 10 raised to minus 5, R is equal to minus 100. Okay, now how to calculate? Okay, directly calculation with the help of calculator. Okay, next time we will do the calculation. Okay, here now 10 raised to 5 common, it take common. By with the help of matrix calculation we can find out, we will get the answer. So with the help of calculator. Okay, there is no need to use your personal knowledge, because for the calculation the time will required will be maximum. Okay, whatever we will, for the next problem we will study how to calculate. Okay. Now by solving simultaneously this matrix, we will get the answer U2 is equal to U2 and U is nothing but the displacement at point 2 and R is nothing but the reaction force. Okay, is it right? 58. Left केले का मुलांनी? No. Okay, so we get the different values. Okay, so epsilon is equal to U2 minus U1. Definitely we know formula. Epsilon strain is nothing but change in displacement upon length. Okay, change in displacement काय आपण U2 मिळाला. U1 we have taken a 0 here. Why U1 we have taken 0 here? In problem. Wait. Here U1 value is we have taken why? Because U1 is fixed. Okay, and U2 value I will discuss in detail. The screen is visible, all of you. आता बघा कंटाळा आलेला आहे तुम्हाला सगळ्यांना बरं का. तेव्हा मला प्रॉब्लेम काय घ्यायचा नव्हता, आता प्रेस मध्ये घ्यायचा होता. Okay, we had can suppose suppose this is a point 1, this is a node 1, okay, and this is a node 2. Okay, this is a node 2. I will change color. Okay, this is a point 1 and this is a point 2 or node 2. See here. Now here 1 is nothing but the node number 1, which is fixed. Now see here at the end of this image. Okay, 10 raised to minus 5 into 4 minus 5 minus 4 minus 4 4 into U1 U2 and F1 U2 is equal to F1 F2. Why we have taken U? Because two nodes are there. If we will get the problem for the 3 nodes, then you can add U3 also, F3 also. Okay. So point number 1 and point number 2 is nothing but node number 1 and node number 2. Suppose put the value U1 and U2. What is the value U1 value? U1 is nothing but displacement at point 1. Okay, due to our bar is fixed. Okay, there will be not displacement. In calculation, in problem statement they have given calculate the displacement and stress. Okay, so you equal to F1 and F2. F1 is nothing but force at node 1 and force at node 2 is nothing but F2. Now F2 they have given 100 Newton they have given, but what is the force at point 1? Okay, the reaction force will be definitely there. Okay, now that reaction force we have to calculate. Okay, hello. So now only calculation is remaining. Okay, only calculation is remaining. So here by calculating this matrix, okay, you will get. I will give information about the calculation. Okay, by using calculator, I will give live demo. Okay, live demo. Now U2 and R value. Okay, after that, getting U2 and R value, find out the stress and strain. Okay, in problem they have given only for the stress. You can calculate directly strain also. What is strain? Change in displacement upon length. Okay, length is given 10 mm and change in displacement U2 minus U1 and only one stress is there. Why? Because one element is there. Okay, so node is equal to one element. Sorry. So so the value of stress is equal to 25 into 10 raised to minus 5 minus 0 upon 10. Okay. So strain value is nothing but 25 into 10 raised to minus 6. Okay. Newton per. Sorry. What is the unit of strain? Okay. Force Newton per mm. Okay. So sigma strain is equal to change in length upon. There is no unit. Okay. Because of so sigma is equal to epsilon 1 into strain. Okay, for this sigma calculation we have to require the strain value. So put the direct value and we will get the value. 200 into 10 raised to minus 3, sorry, 10 raised to 3 into 25 into 10 raised to minus 3. Okay, after calculation, sigma stress at point 1 node is equal to 5 Newton per mm square. Okay, this is the only formula. Now, what we have studied only, we have to calculate displacement and stress. What is the displacement calculation? We have to use the stiffness formula and the standard force formula. Only two formula we have used. Okay. So again tomorrow, again next lecture, we will discuss about the next problem. Okay. We have taken 2 or 3 problems for this article. Very simple problems are there. Okay. So please give the attendance, all of you. We will stop here today. I will call your roll number. Okay. So directly 2-3 problem we have to take tomorrow. Okay, our next lecture. If you have any doubt, so please ask me, please message me. Okay. मग actually कोणीतरी विचारला पण ते काय पुन्हा कोणी विचार माझ्या लक्षात आलं नाही. ओके, नोडचा विचारला होता ना, ते क्लिअर झालं का बघा. आणि फॉर्म्युला जे आहेत व्हेरी रिग्रेस कॅल्क्युलेशन आहे, त्यामुळे मी इथे घेतलेलं नाही ते. आपण नेक्स्ट टाइम जरा वेळ काढून घेऊया चांगलं. ओके, ओनली वी हॅव सॉल्व्ड वन प्रॉब्लेम टुडे विथ द हेल्प ऑफ 2 formulas. Okay, these are the standard formulas. Okay, so please give the attendance. Roll number 50, Pranay.
Yes, sir.
55. Number 2.
Yes.
Yes, sir.
Number 3. Number
Yes,
5.
sir.
Number 8. Number
Present, sir.
15.
Present, sir.
16. 23.
Yes, sir.
25. Yes. 34.
Present, sir.
38. 38 Saurabh.
Yes, sir.
46. 54.
Yes, sir.
57. Pritam. 58.
Present, sir.
62. 65.
Present, sir.
71. That is very
Yes, sir.
less. So,
Sir, TA15.
so
Sir, 46.
46 I have taken.
Sir, 15. 1-5.
1-5 is also there. म्हणजे जेवढे जेवढे आहेत ते घेतले रे. So tomorrow or next lecture, okay, we will today again this type of problem.